Yeah, good afternoon to all of you. Welcome to the second session on air pollution control engineering course. Quickly, we recollect what we discussed in yesterday's class. We uh, discussed the air pollution sources. So basically, there are broadly two types of sources you have come across: the natural source and anthropogenic sources. Then within the anthropogenic sources, you identified uh, again sub-classifications: a point source, emissions coming from the industries; then line source, emissions coming from the vehicles; and an area source, emissions contributed by domestic burning or domestic emissions or open burning, etc. We also learnt the different types of pollutants that are coming to because of this combustion activities, primary pollutants and secondary pollutants. And some of the primary pollutants are basically depends on the kind of fuel we are using. And if you are using uh, coal, then you will come across sulfur dioxide, oxides of nitrogen, particulates, and unburnt hydrocarbons. And similarly, you will also learnt about the secondary pollutants, which basically forms because of the interaction of some of the primary pollutants, for example, ozone and polyaromatic hydrocarbons. Then we discussed about the health impacts that are caused due to these air pollutants. That basically they will cause a short-term impacts and long-term impacts. Involves a respiratory illness to the serious health lung infections. We also look at what is the philosophy. Now we know that there is a major air pollution problem. What is the philosophy to control these emissions? We looked into that two types of air pollution control philosophy generally followed. One is short term, another one is long term. For the short term air pollution control philosophy, we have given an example of an odd even policy which is practiced in Delhi to reduce emissions contributed by vehicles. Then a long-term control strategy involves through policies such as Euro norms or Bharat stage norms, Bharat stage 4, Bharat stage 5. We discussed about it. Then we discussed the different types of measurements of these pollutants. So we looked into in situ measurements. Then we also discussed about on-site measurements. Okay. Then we also understand what are the different types of extractions we can use for understanding the characteristics of the pollutants that are existing in the ambient environment. So we also come across different types of standards in order to understand whether a particular source is contributing significantly or not. We also learned about source monitoring. Source monitoring also involves with a sampling train which require a probe and media to collect the samples. It can be an absorbing media or a filter, then followed by a pump, and then you have a flow meter to measure the flow rate. Okay. Then we also used the various measuring equipments that is being used in India. Then we also discussed about how this air pollutant measurements are being used in declaring a non-attainment area. A non-attainment area is nothing but area in which the air quality is not meeting the standards, national ambient air quality standards. So we also discussed about there are two types of standards. One is source or emission standards, then an ambient standards. So emission standards are meant to regulate the emissions at the source, and ambient standards are meant to understand what is an air quality and relating to the health impact. So with this, close the yesterday's section. Now I would like to connecting that to the today's session. So today's section basically, okay, in today's session, so we'll discuss about the air pollution metrology concepts. In particular, you know that whenever the pollutants released from the any source, it will be subjected to dispersion. I'll just explain about what is dispersion. That depends on atmospheric stability. So we have two types of stability. One is dry adiabatic. Okay, this stability will be defined with an characteristics of the pollutants at which it disperses from one location to the other location, or one height to the other height. So we call it as a dry adiabatic slab state and wet adiabatic slab state. Then we also understand what are the different shapes you will come across because of the atmospheric stability. After that, I'll try to introduce the control of air pollution, what is the engineering control concepts and various devices and their applications in addressing the air pollution. Then finally, I'll going to conclude this session with air quality modeling. Involves with physical principles and different types of models and their uses. Okay, let us try to understand a troposphere where most of these air pollution problems are associated, and all of you know that temperature decreases with height. So that's why when the emissions are released from the source, so the emissions temperature will be much higher than surrounding environment. That's why they are trying to rise, and hence they will get more volume, then concentration will decreases. Okay, now I quickly recollect some of the pathways of the air pollution. So there are different sources we have discussed about yesterday: the industrial emissions, domestic emissions, and transport emissions. If you try to quickly recollect, about 60 to 70% of the emissions in the urban area are contributed transport sector or vehicles, and about 10% from the domestic or other emission sources, about 20% from the industrial sources. These emissions will be subjected to transmission. So the dispersion, or basically we call it as an it's a dilution plus advection, a molecular diffusion plus advection. Sometimes if some of the primary pollutants, if they involve some reactions, then we need to consider that also while transmission of the pollutants. The transmission of the pollutants in general depends on meteorology, the wind speed, wind direction, and atmospheric stability. So these whole things resulting into ambient pollutant concentration. Sometimes some of the particulates can also deposit it. We call it as deposition of particulates. So if you try to understand if you emissions, once they're released, the meteorology plays an important role in determining the ambient pollutant concentration. So that's why we are interested to understand how to relate the ambient conditions with reference to some of the meteorological parameters. Now first, why do we need to study meteorology? So it influences the pollutant dispersion, it influences the pollutant transport, helps to locate air pollution monitoring. Yesterday I also mentioned about how to locate or where to locate your monitoring station. So I told you, suppose if this is a road and vehicles are moving, and if the wind is coming from this direction, where are you locating the monitoring station? So you try to locate on the downwind direction so that you will be able to capture the emissions contributed by the vehicles. Okay, so it helps to locate your monitoring stations, help to develop implementation plans and bring ambient air quality into compliance with standards, then help to predict ambient impact of the new sources. For example, if you know the meteorological conditions, you can able to understand whether the environmental conditions are sufficient to carry the load contributed by various activities. So you can also use the meteorological informations to predict air pollutant concentrations. Of course, you can link between global warming and climate change. These pictures might have been already you might have seen earlier. So this will indicates that a valley breeze and a mountain breeze. So in the daytime you expect a valley breeze, and in the night time you expect mountain breeze. And if you recollect, sometimes the valleys are the sources of water. Generally rivers will flow in valleys. So industries also located near the river. So hence the emissions contributed by the industries, especially during the night time, they will all going to accumulate, and significant air pollution episodes you can come across. So especially if the cities are located in a coastal area, you will come across this land breeze and sea breeze, and that is one of the reason. Mostly the coastal cities in general, the pollution levels will be less because of better dispersion conditions. Of course, if the land use pattern and the building arrangement can affect this kind of flow and increases pollutant concentrations. So generally during the daytime you will come across the sea breeze, and night time you will come across the land breeze. You also come across another important phenomena. This is called urban heat island effect. On the city center, if you notice that it is much warmer, and if you go away from the city, so this phenomena we call it as an urban heat island. I will connect this in the tomorrow's discussion. You know that cities generally movement of vehicles will be more, so more carbon monoxide and carbon dioxide concentrations will be released, and carbon dioxide concentration in turn can warm the local area, and hence the temperature will be much higher when compared to the surrounding environment. As a result, if the air becomes warmer, then they can try to move away from that. As you all know that depending on the pressure gradient, air mass try to move from one location to the other location. So this gives another information. So when the buildings are arranged, so when the wind flows here, you will come across canopy, wake layer, and surface layer and mixed layer. So canopy sometimes, if the both, for example, between the roads on both sides you have a tall buildings. So then you will come across a canopy. Then we call it as a street canyon. And if emissions are very high and probably significantly, your concentration will be accumulated, pollutant concentration will be accumulated in this region. So this gives a complete picture of when the emissions contributed by a thermal power plant, then if emissions releasing from the stack, so you have a physical stack height, then because of the buoyancy effect and the momentum effect, you will notice there is a plume rise. Okay, so this plume rise will in turn will determine the concentrations that contributed by the emissions. Sometimes because of rain, it can wash out. Okay, then some of the heavier particles can follow. Okay, the principal parameters for air pollutant transport and dilutions: temperature. You all know that the air mass moves from higher temperature. Temperature will be higher, so it's a move as it tries to move upward. Okay, so humidity also plays a very important role. It also involves in determining the pressure, and also it enhances the chemical reactions within the environment and the given conditions. The pressure, so as you all know that air normally move from high pressure to low pressure regions. Again, wind speed, which determines in which direction or which way the pollutants are moving. Then wind direction, generally now the instruments give every 1 degree frequency of the wind cycle, but in the earlier, for understanding, you can classify the wind speed into 16 directions and make use of which is the predominant direction and determine which is the best locations to keep the monitoring station. And also in planning the residential area and industrial area or commercial zones, you can use this wind rose diagrams. The mixing height is another important meteorological variable which plays an important role in determining the concentrations. You all know that mixing height is nothing but up to an height, the air pollutants released from the source will try to move upward. Okay, so the mixing height generally will be very high during the summers and daytime, and low during winters and night time. So if you notice that winters, the mixing height will be a few hundred meters, hence the less volume is available, and since the source is more or less same, so all the pollutants which are released from the different sources, they all accumulate. So since the volume is less, you will notice more concentrations during the winter season. Whereas in the summer season, you will come across a very good mixing height, hence you will have more volume, and the concentrations will be very less. I also indicated in the yesterday's discussion, we have two types of episodes, winter episodes and summer episodes. In the winter episodes, pollution concentration increases because of the mixing height and accumulation of the pollutants within that mixing layer. Whereas in the summer episode, you will come across the pollutant concentration increase because of the chemical reactions. Ozone concentration increase because of oxides of nitrogen, sunlight, and hydrocarbons. The next important parameter which determines the air pollutant concentration in a given environment is the amount of turbulence. Okay, the amount of turbulence in the ambient air will indicate that how good the dispersion is happening in that particular place. So this amount of turbulence is categorized into different stability classes. The most widely used stability class in determining the turbulence is Pascal stability classes A to F. Now try to understand lapse rate. Lapse rate is defined as a negative rate of change of temperature with altitude. Now you try to look at this is a temperature and height. As you move upward, the temperature decreases with height. So this is a very good for air pollution dispersion, air pollutant dispersion. So in general, if you try to look at a dry adiabatic lapse rate, where the temperature decreases closely about 1 degree per every 100 meter, so about 10 degrees centigrade per 1 kilometer. Whereas wet adiabatic lapse rate is approximately about 6 degrees centigrade per kilometer. As you know that, so since it is having a humidity component, the rise of air or movement of air is much less when compared to dry adiabatic lapse rate. Now depending on that, you can classify the conditions into superadiabatic conditions, subadiabatic conditions, and inversion conditions. The superadiabatic conditions, as I mentioned to you, is a very good condition which explains the better dispersion conditions. Subadiabatic conditions, more or less the rate at which the pollutant is rising, it's a very slow, but still it involves some amount of dispersion. The inversion condition is very bad for air pollutants because it accumulates all the pollutants released from the various sources, causing many episodes, air pollution episodes. This explained about different stability classes. You have noticed stable atmosphere. It means that there is not much change in variation in losing the temperature from the air mass from the emissions released from the stack to the surrounding environment. Unstable atmosphere, as I told you, it is a very good. So the air parcel releasing from the any stack will try to lose its temperature adiabatically. So hence there is a better dispersion. A neutral stability atmosphere is rising air parcel will try to move upwards with equivalent to dry adiabatic lapse rate. So inversion condition is a special case where you notice that instead of temperature decreases with height, it is increases with height. Now you imagine there is a air parcel which is having a temperature about 20 degree and the surrounding temperature is 28 degree. So it means that the surrounding air is much warmer than the air mass which is released from the source is when compared to the source. So hence this will not go rise up because surrounding air is already warm. So hence this will create some kind of an inversion layer, hence you will have more concentrations in that particular area. So this gives some information about different types of plume shapes you will come across. This fanning shape you generally come across. You try to look at the stability class here. So the dotted lines gives the dry adiabatic lapse rate. Okay, this one gives the environmental lapse rate, the present condition or current conditions lapse rate. Now in this case, on a given day, if the temperature increases with height, so what will happens? The pollutants, okay, if you are releasing at certain height, so it will not spread. It will only move in a form of a fan shape. Okay, next comes is a fumigation, and now you try to look at So in this is a neutral stability, and then you have a stable atmosphere. A stable atmosphere means increase in temperature with height. So hence what is happening, all the pollutants which are released from the stack will be get accumulated and moving towards the ground. Looping is again, it's a good for dispersion. Generally happens unstable conditions because of the unstable in atmospheric nature. So you will notice a significant loop or plume is spreading in a form of a loop. The next shape you will come across is a coning, just like a cone shape, ice cream cone, you can recollect. So you see that the ambient lapse rate and dry adiabatic lapse rate, the temperature gradient is more or less same. So in this case, you will notice coning shape. Lofting is another type of plume behavior. It is opposite to your fumigation. So where you notice that on the just on the up to the tip of the stack, it means that some height from the ground level you have a stable atmosphere. After that, it is a neutral atmosphere. So it means that pollutants are only moving above that stable atmosphere. So there is a possibility for it to disperse. So once this, in both the cases, in this case, if the layer breaks, then you will have significant concentrations at the ground level. Then trapping is, if you notice, there is a change in gradient. Initially it is an inversion, then there is a stable atmosphere, again it is an inversion conditions. So between the inversion conditions, if the stack is designed to locate in that area, then the pollutants will get trapped. So then again, if the inversion layers, these layers breaks, then you will get maximum concentration, ground level concentrations. Now, how to determine this stability class? This is a very important. You can you need 3 important parameters to determine stability class, Pascal default stability class: wind speed, solar radiation, then your cloud cover. So now if you try to look at the wind classifications, there are different wind classifications, and here these columns gives you the different stability class. Okay. So, so for example, if the measured wind speed is 2 meter per second, and you notice that there is an incoming solar radiation is 143 calories per meter square per second. Okay, then you can identify that as a stability class A. Suppose you have a night time and you wanted to find out what is the stability class, then you can use a cloud cover. So depending on the cloud cover, you can there is a octa is been a unit for measuring the cloud cover. So if it is a completely cloudy, when you go and see outside, if it is completely cloudy, you can put 8 out of 8. Okay, so depending on the ratios of the cloud cover, you can determine the different stability classes for the night time and the daytime. Okay, so even in the daytime, if the sky is overcast, it means that completely cloudy, then the stability class will be D. Okay, so you will use the stability class to understand what is the dispersion that is happening in a given environment. So for example, so you would like to know, suppose emission is contributed from the a power plant, and you would like to know how the dispersion is taking place. Generally on the direction of the wind, so this is your wind. So in this direction, advection is dominating. So this is, if you call it as this is a plume center line. Okay, so this will be the plume center line. So the dispersion can take in those 2 directions. So dispersion can happen here and also in the lateral directions. So these, the spread, so it will be the spread will be determined with the sigma y and sigma z. That will be estimated with this chart. Okay, so you know the downwind distance. From the downwind distance, you find out what is the dispersion coefficient. For example, you know the stability class, you know the wind speed. Okay, you know the solar radiation, and if the cloud cover, if based on that you determine the stability class, and from the corresponding stability class, and you with reference to your emission source and you are interested to find out the concentration at a particular receptor. In this case, so I am trying to find out, suppose you would like to buy an house in an apartment, and so you would like to interested to look, okay, which floor I should go for. So you notice that at 10 kilometer away you have a power plant, and probably you can use this a simple dispersion equation to find out what is the concentrations. So that will determine you, okay, which floor you can identify based on depending on the concentration, wind directions. Okay, so you can, this we call it as a receptor, the receptor at which you are interested to find out the concentration. For example, if you are trying to measure at your, if you are interested to measure at a parking area, then it will become a ground floor. So ground floor, it will become, Z will become 0. Okay, so that I'll going to explain to you, and once I'll come back to the mathematical equation. I just wanted you to recollect this. We call it as an X is nothing but a downwind distance from the source. What is the distance you are interested to find out the concentration? So that will be, so you know the source and you know the emission stability class, and find out sigma y and sigma z values that will be useful for understanding the dispersion in that particular area. Okay, another important aspect in air pollution control engineering is wind rose diagram, wind and pollution rose diagram. So you can classify the whole wind data into 16 classes, which I mentioned to you, and you can also distribute the frequency of wind speed into different categories. Like for example, in this case, I've used 1 to 2 meters, 2.1 to 5 meters, 5.1 to 7 meters, 7.1 to 9 meters, 9.1 to 14. Like that, I just made some classifications. And suppose if you taken a 1 month data or 1 year data, and you can classify the what is the frequency, number of hours the wind will be coming from these directions. Now, so for example, in a 24 hours, if all the 24 hours wind is coming from north direction, so it then at a rate of 1 meters per second, then all the 24 values will come only here. Then you can also try to get some data on pollutants concentration. For example, you have a SO2 concentrations or NO2 concentrations measured at that particular area. So if the wind is coming all the 24 hours, just to get an idea for you. So in this case, if you try to look at, so now your receptor is located here, and wind is coming from this direction, this direction, this direction, and also from this direction. On a given day, if all the 24 values are coming from this direction, so then what is the concentration here? Suppose if this is the source, then obviously you will going to get maximum concentration. Suppose in a given day, 6 hours is coming from this side, 6 hours is coming from this side, 6 hours is coming from this side, 6 hours is coming from this side. Then what is the concentration? So you will going to get these informations. So in this case, I'll try to put this is your north, and this is south, east, west, okay, northwest, okay, northeast. So now, so if you input those values and corresponding concentration, you can get both a predominant wind speed or wind frequency distribution and also pollutant concentration distribution. So this is very important for you to determine where exactly you can place your monitoring location, so that you will be able to capture the purpose or objective of the setting up of monitoring stations in that particular area. This will also help you to understand what is the risk associated with various sources in terms of exposure. Exposure to the different pollutants released from the various sources. Okay. Now I'll move on to connecting to an air quality management plan, and this is very important for us to understand the various control equipments. Let us try to look at, we discussed about the air pollution monitoring in the first session, and that air pollution monitoring will indicate what type of sources contributes pollution. Which source contributes pollution. For example, I told you in an urban area, if you notice that SO2 concentrations are very high, okay, all of us know that SO2 concentration will come from only in case if the diesel vehicles, but right now we are using very low sulfur diesel, okay. So hence, if you get sulfur concentrations in an urban area, it clearly indicates that somewhere the coal-fired power plant is maybe the source for the sulfur concentrations. So based on your measurements, you will be able to understand which source is contributing pollutants in that particular area. You can also use some informations related to health. Okay, suppose you have an health data, and correspondingly, if you notice respiratory illness, okay, skin allergy or high irritations, you can link it out which type of pollutant is causing that one. Either it may be an oxides of nitrogen, sulfur dioxide, you can find out that. Okay. So if it is a lung capacity reduction, again you can relate it which pollutant. So either with the hospital admission data or with the monitoring, you will still able to locate, or you can able to identify in general which source contributing some amount contributing pollution in that particular source particular area. The other aspect which I mentioned to you is a source apportionment. Suppose if you have a information on the monitoring and you use those filter, for example, you want to quantify which source is contributing. I just mentioned about in the earlier slide that there are different sources that contributes, line source, area source, point source. I just mentioned about 70 to 60 to 70% is from light source. How to indicate that 60 to 70%? So you can use source apportionment studies where you are apportioning the pollutants that are contributed at a given environment. What are the different sources that contribute? That can be apportioned using source apportionment. So in this case, you are using the chemical species signatures to relate it to the ambient chemical species signatures which you measured at particular area. You can also do another exercise, we call it as an emission inventory. Yesterday we also learnt about quantifying emissions using an emission factor and an activity, and you can know that what are the different activities that is happening in a particular area, and if you know the emission factors for all those activities, you can still able to quantify which source is contributing significant emissions. Quickly to give you an example, for example, in an urban road, so you notice that there are 1,000 vehicles. So out of 2,000 vehicles, in general, you notice majority will be two-wheelers. Okay, so about 40 to 50% will be two-wheelers. Another 30%, 30 to 40% will be four-wheelers, cars, and remaining will be heavy vehicles. Now, if you try to look at in terms of numbers, two-wheelers are more, but they are not really contributing significant amount of emissions because they are all gasoline powered, and their emissions will be less. But heavy vehicles, their emission factors will be very high, even though their percentage very less, so their contributions will be much higher. So your emission inventory will able to identify which source is contributing emissions in that particular area. So now we are using these source informations in the form of modeling. Here modeling will take care of two sets of informations. One, informations related to the source, another one, the informations related to the dispersion conditions, the metrology. So you will able to decide the various control strategy you can adapt at that particular area. Again, cost benefit analysis you can think of, okay, in reducing or in implementing. For example, any policies which you will trying to implement, okay, whether the people or public will accept that one. So if it is acceptable, then you implement it, then see that there is a improvement in that. I'll quickly give you an example. So earlier, if you notice that we have a leaded fuel, and the government has banned, and now we are using only unleaded fuel for vehicles. Now because of that, now if you do any measurement in the ambient environment and the roadside, you will notice that lead concentrations are very less. So it means that the policy which is implemented, and you will try to see that their concentrations have been effectively reduced. Okay, next coming to an air quality management by system approach. Now this is very important. I just mentioned about the different sources of air pollutions that are contributed. I introduced about the metrology. Now we will try to move towards controlling engineering controlling. Okay, at source you have some options available to you. You can use control equipments, you can use process modification, you can use fuel modifications. I'll take some time to explain about the control equipments. First, let me finish it about fuel modifications. For example, you notice that diesel is contributing significant amount of pollutions. What is the solution? Possibly you will going to suggest use CNG vehicle or electric vehicles. Then coming to a process modification, sometimes a small changes in the process itself can reduce the amount of emissions that are contributed into the environment. One such example is earlier all our engines used to be two-wheelers used to be two-stroke engines, and it has been converted to a four-stroke engines. So now because of that process modification, a significant pollution have been reduced, load has been reduced. Now coming to a control equipments, so once the source combustion is contributing emissions, before the emissions releasing into the stack, so you will try to adapt some control mechanisms. So I will discuss detail after this slide. So that is you will going to adapt some of the control equipment. At source, these are some of the opportunities available for reducing the emissions. Then coming to the transportation, now the emissions are coming out from the source, just like emissions coming from your tile pipe, emissions coming from your power plant stack. So then what is the opportunity that is available? So for example, if I try to give an example, if emissions are coming just towards you, okay, or you are just standing exactly on the facing to the exhaust pipe of a vehicle. So what you will do, when the moment the vehicle starts, a lot of emissions will come towards to you. So what you will do, you quickly try to move away from that. So the transportation of this pollutant also helps in avoiding exposing the pollutant concentration that is releasing from the source. So it means that the dispersion model will help you to locate which are the areas you will going to get a maximum concentrations, so that, and what are the control mechanisms you can adapt in order to meet the requirement. For example, your ambient air quality standards has to be met in a particular area, then you will try to understand what control mechanism that need to be adapted, that can be determined through your dispersion modeling. There are two types of modeling, I will discuss in detail about it, mathematical modeling and physical modeling. So again, if these two are over, at the receptor there is no option, you have to cover yourself exposing to the pollutant concentration. Let us try to look for the control of air pollutants. There are different mechanisms that are available. I will just explain about some of the concepts that are being used in controlling these pollutants. So broadly we will classify the pollutants into two types, particulates and gases. So particulates, if you know, one of the advantages, they have a density, so you can use all the physical forces that is possible for us to remove. Say for example, settling chamber, so you can use the gravitational force, then inertial separator, then induce some additional force and try to eliminate from the path, then cyclones, filters, electrostatic precipitators, scrubbers or wet collectors. For gases, settling is not possible because they are all very fine in size, so they will take several days to years to settle down. So we can't use gases, we will use either incineration, absorption, adsorption, masking. Okay, let us try to look at if the particles are coming, then they will be subjected to a Brownian motion. So that is one way of, if there is a collector, so because of Brownian motion they will come and attach. The other one is interception. So because of the flow path, because of the obstruction, they will get intercepted, or it will be subjected to direct impactions. So these are the key mechanisms that are being adapted in designing the various air pollution control equipment. Now try to look at some of the control equipments that are available. So based on the gravity forces, you will be having gravity settling chamber. Okay, so for example, sudden expansion. Okay, so when the flow is being coming from the source and immediately it is expand, what will happens? The velocity of the flow will be reduced, hence there is a opportunity for all the particles to settle down. And multi-tray settling, so you can also provide a series of trays so that again your particles will be having a less vertical distance to travel, hence it will also increases in collecting those particulates. Then you can use a centrifugal force, cyclones, many times you will come across cyclones used in various applications depending on the type in which you are providing the inflow. A top inlet cyclone, bottom inlet cyclone, axial entry cyclone and tangential entry cyclone. So there are different types of cyclones. Then based on the impaction, interaction, interception and diffusion, so the baghouse will be designed. Then electrostatic attraction, using electrostatic forces, you will going to design electrostatic precipitator. Then coming to the wet process, again you will have use impaction, interception, diffusion. The wet scrubber, so generally Venturi scrubber is a very efficient, plate tower, orifice sub scrubber, liquid phase contacting scrubber, spray tower, ejector venturi, then combination of gas and liquid phase contacting scrubber, cyclone separator, mobile bed scrubber. So these are all some of the process that are being used in removing the pollutant. Okay, so let us try to go in detail about the gaseous pollutants. So for example, a settling chamber will not be useful for gaseous pollutants. So gaseous pollutants will be used. Wet scrubber is one which can address both gaseous and particulate pollutants. So wet absorption scrubber can use for removing the particulates, and in particular adsorption and condensation and incineration. These are the four mechanisms that have been widely used in removing the particulates from the gas stream. Let us try to look at a settling chamber. Just if you look at this figure, so there is a flow and there is an immediate expansion. The velocity will be reduced, and all the particles having settling velocity more than the velocity of the gas, they will all settle here. So generally, the settling chamber uses a gravity settling force, and generally used will be for the large size particles of size greater than 75 micron. So as you can immediately come to a conclusion, we can use this as a pre-cleaning equipment. So some advantages: it is a low cost, low energy cost, it is having no moving parts. Okay, so hence operation and maintenance cost is very less. Okay, the one problem is you can also have dry collection will be there. You can use it for various other purpose, the fly ash and other things which is collected. For small size particles, it is not very effective. Actually, as I mentioned to you, this is a very good for large size particles. If the particles have some sticky in nature, then this will not be very effective. That's another issue with settling chamber. So these are the equations that is being used for calculating the efficiency of the scrubber. So I'll quickly tell you that L and H are the dimensions of the settling chamber, length and height. D is the diameter of the particle, density of the particle, acceleration due to gravity. This is the velocity at which the gas is flowing. Mu is viscosity of the air. So there are two types of flow you can come across: block flow and mixed flow. The next is a bag house. Okay, basically you will use a filter media, and you allow the dirty gas to pass through this filter media. So the mechanism involved is here interception, impaction and diffusion. Okay, so now you need to find out what is the filtering area required. Okay, cleaning cycle, because the bag house once it is collected, you need to frequently clean, and pressure drop. So here you can do a design cycle. What you can know, you need to know is, the flow rate which is coming from the stack, and you need to find out for the given flow rate what should be the air to cloth ratio. So then you design what is the cloth area required, then design number of the bag house, and you identify number of compartments, and determine the total filtration time as run time of the filter plus run time of the cleaning time of the filter. Okay, so here one compartment you are keeping it for cleaning purpose, so there will be 1 minus Tc. So in general 1 to 5 minutes will be used for cleaning of the filters. See the back filters when you design. Okay, so you will come across the number of back filters. You can arrange them in a different shapes. Okay, so either you can put them in a rectangular, square, depending on the requirement. So you can identify number of bags required. Keep one compartment as an extra. You can design the number of number of bags required for each compartment, and then keep one compartment as an extra to use it for cleaning purpose. Now, other issue you need to be consider while designing a bag house is how to collect the particles that are collected in the bag house. Either you can use a shaker. So after few times, okay, the bag house will get a shaking mechanism, or you can use pulse jet or sonicon. So these are all some of the mechanism you can use to remove the particles that are collected on the filter bag house inside the bag house. Since bag house is as the name you are filtering with a cloth, so it is having an higher efficiency, extremely flexible. Okay, volumetric capabilities in you can still meet that. Reasonable operating pressure drop, then ability to handle diversity of solid materials. So now some disadvantages, the space factor, because if you want to go for a large size, large volume of treatment of flue gas, then you need a more space. Then the other problem associated, for example, in any combustion emissions, sometimes the unburnt hydrocarbons will be releasing. So these hydrocarbons, if it is captured within this bag house, then what will happens because of the temperature, they can subject to some explosion. Okay, if the moisture is very high, then bag house efficiency will be very less. So then you need to go for some frequent cleaning. Bag damage is some of the things you will come across. So generally you will use the bag house if the size classification is not required, high efficiency is required, and you can also would like to collect some materials from your flue gas, and you want to treat a less volume of air. So generally used in power plant, fertilizer, food processing industry, paper mills, and ore processing. The next type of control equipment is electrostatic precipitator. So I just wanted to quickly to connect it to you. So if you try to look at this is a various combustion activities, then that emissions will come from here. Then this electrostatic precipitator will be connected before releasing the gas to the stack. So now we are talking about at source. Okay, we are using different control equipments. We have used bag house, we have used settling chamber. Okay, so now we are trying to see how the electrostatic precipitator can be used in removing the particulates. So this diagram gives how the electric charges help in removing the particulates. So if you try to look at the electric charges, in general you should note that the most of the particles that are existing in the ambient environment, they are all negatively charged particles. So now if you induce some more electric force here, so we have a positively charged plate, so all the particles will be get collected here. So the distance which is traveled by the particles from this pole to the plate, we call it as a drift velocity. So now you can also think of, so if you try to look at it, if this is the length of the plate, okay, so then as the distance moves, you can also vary the voltage, and because at the entry itself, the more particle concentrations will be there. Once it is released, so you may have less concentrations of the pollutants, hence you can also give a varying load of electric force, so that in order to reduce the cost. So again there are two equations generally used for block flow and mixed flow. This is the Desplat-Anderson equation has been used for calculating the efficiency. W is the drift velocity, area is the A is the plate area, Q is the flow rate. So you can find out what is the efficiency. So now coming to an advantages of the electrostatic precipitator, it is an high efficiency, even small particles can remove. That is why in most of the industries, electrostatic precipitators have been used. Even in some of the indoor air pollution control, electrostatic precipitators also used. Low pressure drops, it's possible for you to dry or wet collection, wide range of temperature, low operating cost. Disadvantage, high capital cost, because this involves a lot of investment in setting up of all the plate charges and other things. It takes up lots of space, not flexible to change. Suppose if you change the load to now you have designed an electrostatic precipitator for 500 megawatt, and now you wanted to go it for increasing your capacity to 750 megawatt, then obviously you can't use the same electrostatic precipitator because your flow has increased. So in such cases it is not flexible to change. Okay, may need a pre-cleaner at the high concentration. For example, for electrostatic precipitator, before that if you keep some cyclone separator or maybe settling chamber so that large particles can be removed, or if other gases which can interfere in electrostatic precipitator, that can also be eliminated. Okay, so you generally use this again in power plant, cement plant, paper mills, steel foundries, and indoor air quality, as I mentioned to you. The next important type of control equipment is a cyclone separator. Basically, it uses centrifugal force. Okay, cyclone separators usually employed if the particle sizes are greater than 10 micron. Okay, so since cyclone separator designed based on your centrifugal force, so the size classification, particle size classification is very, very important. So cyclone separators, as I mentioned to you, it can be used again as a pre-cleaning system before your electrostatic precipitator or baghouse. So advantage is it is a cheap, there is no moving part, only you are connecting the flow to into the cyclone separator, then removes the solid or liquid particles. It can work even for higher temperature. This is an widely used technology since 1940. It is being used, so it is a time proven technology. Some disadvantages, if you, as I mentioned, for small size particles the efficiency is very bad, high pressure drop, high operating cost. Again, similar to your settling chamber, if the particles are sticky in nature, this cyclone separator will not going to work. So there are different types of cyclone, as I mentioned earlier. Depending on the entry of the gas into the system, you can have a top inlet, bottom inlet, axial entry, and tangential entry cyclones. In terms of efficiency, the cyclones are also classified into high efficiency cyclone, high throughput cyclones, a conventional or standard cyclone. So quickly to give you, I'm not able to give you complete details of derivations of this equation, but I'll try to give you the key points that you should remember in designing the cyclone separator. Now we try to understand now the particles which are present in the gas is entering to the cyclone system, and this cyclone system, within the cyclone system the particles has to move, and it has attached to the surface, the inner outer surface of the cyclone. So okay, now it means that the number of rotation the particles has to carry out in the cyclone has to be designed. So Ne 1 by H, Ld, Lc by 2, these are all dimensions of the cyclone separator. You can use that to calculate number of rotations. Then the next is, if you know the number of rotations and if you know the diameter of the cyclone, you can able to find out what is the distance these particles travels. So you can use that information to quantify how much time the gas or a particle spends within the cyclone. So this we call it as a gas residence time. Okay, so Vi is your inlet gas velocity. Okay, now you want to find out, you are equating centrifugal force with a drag force and try to find out the cyclone efficiency. So we are interested to estimate the efficiency of the cyclone for a given diameter. The first step for the given width and volume density. So you can find out what is the diameter that can be designed. Okay, so but we are interested to collect a 50% efficiency, because you know that you can't expect only uniform size particles in the gas. Okay, so you will try to find out what is the 50% of the cutoff diameter or the cut diameter that can be used for designing the efficiency of the cyclone. The cut diameter of the cyclone is defined as size of the particles collected with 50% collection efficiency. For example, in a given emissions, the size of the particles ranging from nanometer to micron. So you are designing a cyclone, as you know that cyclone is very good for 10 micron, above 10 micron. So if it is for example, if it is become 5 micron, then your efficiency will become very, very less. So you can able to identify, depending on the size distribution, if you are planning to use a cyclone, you can able to estimate what is the efficiency, what size particles you can able to collect from the emissions contributed from the stack or any source. So you can also arrange some detailing for removing the particles once it is collected in the system. For example, in the cyclone system, you can have a slide gate Once it is collected, for after some time you can slide it so that all the particles will become and collected here, or rotatory valve, so that depending on the density, once it is loaded, it will try to rotate, so that it will avoid the particle getting re-entered into the system. Or you can also use discharge screw feeder, so where again it's also make sure that re-entry will not going to happen. Or you can also use automatic flip valve, just like your rain gauge, tip of rain gauge. So you can use that. Once the particles will get loaded, it will just open and it will get collected on the hooper. Then the other important control equipment is scrubber. Scrubber is basically you can use it for both gaseous pollutant removal and also particulate removal. Okay. So the mechanism basically here it is an impaction. Okay, flammable, explosive, high temperature. Then you can use method. Then some disadvantage with scrubbing is it's a corrosion. Okay, so if the water is corrosive in nature, then the material whatever you have used for designing the scrubber will get corroded. Create wet waste stream. So it means you are converting the air pollutants into water pollution. Then you need to remove the collected particles. Sometimes what happens if the scrubber, the nozzles will be blocked because of the particles. So you need to address that one. High power input required to generate well dispersed droplets. The scrubbing, as you know, if you just, it is a best example for the raindrops removing the particles in the urban environment. If the finer the droplets, more particles will get removed, and that's why you need to get finer the drop in scrubbing design. So you need to understand the liquid flow rate and the flow rate of the gas. Accordingly, you can design the droplet dimensions or the sizes. So you can use the scrubber. You have a wet particles that are in hot gas stream. Okay. Then you have a corrosive particles. Then very fine particles requiring high efficiency. Particles are with gas and also need to be removed. Okay. So combustible gases. These are all some of the count. So in such cases, you will going to use scrubber. So power plant, paper mills, food industry. Okay. So steel or metal industry, cosmetics, you will going to use scrubbers. Then absorption is another mechanism where you will try to use some known solvent. Okay, for example, you would like to use remove sulfur dioxide, you can use lime soda to remove the gaseous emissions that are present in the given stream. So you can decide which absorbent you are to be used depending on that. So some you can also remove particulates with a condensation, gases with gaseous pollutants with a condensation. So example, you have a known pollutant, you know that what is the freezing temperature, so you can use that as an input to designing the condensation mechanism. Then you can remove some of the pollutants that are coming in the gas stream. You also come across the flares or direct combustion. So mostly you will notice these things in the refineries. So refineries, the one problem is they have sometimes unburnt hydrocarbons with varying concentrations. Generally the concentrations will be, most of the time it will be very less, and they cannot able to capture by all other mechanism. Then they will use these flares in order to remove those unburnt hydrocarbons. Sometimes catalytic converter is another mechanism where you will try to use pollutants from different sources. Example, in vehicles, the catalytic converter will be adapted in order to remove unburnt hydrocarbons. These are some of the advantages, okay, of the your catalytic converter. Low fuel requirements, lower operating, little or no insulations, reduced fire hazards. Some of these are the advantages. High initial cost. Sometimes the catalyst poisoning will be an issue. Particulates often need to be removed first, otherwise the efficiency of the catalytic converter will be less, and you will also come across a disposal problem for spent catalysts. I think this is a picture which shows some control equipments which we have designed in our lab. So we try to use a small open earth furnace and use the different fuels and try to measure the emissions before it getting into the your control equipment. So this is a small cyclone separator which try to remove the particulates. Then this is a scrubber been designed to remove some of the gaseous and particulate elements, particulate pollutants. So we measure the flow rate and the emission characteristics at the inlet, and we measure the before it is going to the scrubber. So we'll know that what is the efficiency of the cyclone, and we also measure the emissions after the scrubbing, outlet at the scrubbing. So we know what is the efficiency of the scrubber. Okay, so now I'll try to introduce to you to model. First of all, try to understand what is a model. It is a mathematical equation. Try to relate between emissions and the air quality that incorporate transport, dispersion, and transformation of various pollutants emitted into the air. Now, quickly recollect. So we know that there are different sources that contribute to emissions. Okay, so then it will be captured how these emissions will be spreading or moving in the given environment through a model input parameters and meteorological parameters. So two model input parameters basically explains or captures the informations on atmospheric stability and dispersion conditions, and the meteorological parameters, which includes wind speed, wind direction, temperature, basically gives how the pollutants moves from one direction to the other direction are subjected to some chemical reactions. So all these three will relate to give an air quality. Okay, so you can classify the models into different types. So basically, broadly you can classify them into physical modeling, mathematical modeling, numerical modeling, or statistical modeling. A physical modeling is nothing but you are simulate the dispersion conditions from the any source on a lab scale, okay, on a smaller scale in the laboratory. Okay, so one example is wind tunnel. Wind tunnel being widely used to simulate air pollutants dispersion from various sources. Next is a mathematical modeling. When the process of problem is trying to understand how the pollutants is changing its concentration from one time to the other time, that through captured through various mathematical expressions. So you can use either deterministic model or a statistical model. A deterministic model, basically a differential equation, is developed by relating rate of change of pollutant concentration in terms of average wind and turbulent diffusion, which in turn is derived from mass conservation principle. So one example is Gaussian plume model. See, numerical model also come under a deterministic modeling, where you are using some numerical approximation scheme to get derive differential equations, solving the equations to derive the dispersion phenomena. So example for the numerical models are Gaussian puff model. Then you also come across statistical models. In both the cases, you will notice that there are some assumptions that are made, and sometimes you may not going to get good results. So then in such case, you also look for, can we look for statistical models, or you may not having many parameters that required for the other deterministic models. In such cases, if you have only one parameter like pollutant concentration itself, then you can use that itself for developing a model. So statistical model is one such technique which try to relate the pollutant concentration with meteorological and emission variables. So examples, regression and multi-regression models, time series models, hybrid models. You can combination of deterministic and statistical models, artificial neural network models, and neurofuzzy models. Now we will try to look at some of the different types of models that are being used, widely used. Okay, there are broadly we can classify the models into point source models, area source models, and line source models. Okay, so models also classified as a meteorological models, emission model, chemical model, receptor model, dispersion model. So you can also classify the air quality models into different types. Coming to point source models, you can some of the most widely used models, AirMod or ADMS, CalPOF, ISCST3. These are all some of the models used by the regulatory agency to understand the impact of point source emissions on the surrounding environment. Coming to area source, for example, crop burning impact on air quality, you can use AirMod, CalPOF, ADMS. Okay, so box model. These are all some of the models you can use for estimating the pollutants or concentrations of the pollutants contributed by various activities. Then you come across line source models, since you know in the urban environment about 70% of the emissions are contributed by the vehicles. So you also notice that there are many models that are available to quantify vehicular emissions, and most widely used is Caline 4, and in fact AirMod and ADMS, you can also use those models for quantifying the emissions contributed by vehicular sources. There are for Indian conditions, there are general finite line source model, and there is a modified version, Delhi finite line source models also can be used. Now the first question, why we need to do a modeling? So first, what is the benefit of modeling? So modeling helps in assessing the new source of air emissions, assessment of source contributions to the ambient air quality, then evaluation of control options, emergency planning, scientific research, air quality forecasting to supplement monitoring data over large spatial scales. This is a one simple point source model, a Gaussian plume dispersion model. The equations, if you notice, Q is the flow rate emission rate. Okay, 2 pi and sigma y, sigma z. This I mentioned to you. You are using Pascal table or chart to find out the values. These are all again a model input parameters. If you try to recollect from the mathematical flow chart which I mentioned a few minutes back, sigma y, sigma z indicates a model parameters. U is the wind speed, and y is again y. If I would like to, so in this case, y is so now there is a emissions contributed. Now I am just using a okay. This is ground level. I am just making a plan. So this is the source. So now you are trying to get, this is your downwind distance. Okay. So this is your physical stack height, and this is your plume rise. So this will be your effective stack height. Okay, so this distance, suppose your receptor is located on the center line of the plume, if this is the wind speed. Okay, so this distance will become x. Now if the receptor is located about 100 meter, so this will become y. Okay, either this side or this side, this will become y. So the crosswind, this we call it as a crosswind distance. So y is nothing but your crosswind distance. Okay, so y is your crosswind distance. Okay, z is the receptor height, which at what height you would like to measure the concentrations. Okay, so these equations, if you substitute, you will be able to find out what is the concentrations under different conditions. Okay, concentrations in gram per meter cube, emission rate in gram per second, u is the horizontal wind velocity, effective height, sigma y, sigma z are the dispersion coefficients. Now you will come across something called a plume rise, which I mentioned earlier. So there are two forces that influences the plume rise: buoyancy and momentum. Okay, so basically depending on the temperature, so you can notice what is a plume rise, and also you have a fan to pump the emissions. that will also influences the plume rise. Okay, plume rise is important because if you just look at it. So now take a case. So now this is a emissions contributed by a stack. So this will be the initial plume rise. Okay. Now suppose if I increase, okay, or if I increase the temperature, then plume height can also be increased, or if I increase the stack height to this height. So initially stack height is say about 120 meter, so I have increased by another 30 meter. So now the total height will become 150 meter. So now as a result the plume spread will become different. Now you look at it, the volume available for the initial plume and the volume available for after increasing the stack height. So the one reducing the pollutant concentrations in the ambient environment, earlier they used to practice was increasing the stack height. So it means that your dilution, okay, diluting pollution in a given area will be controlled by means of dilution. But there are other problems associated with the dilution. Sometimes if you increase the stack say about 300-400 meter, so all the pollutants will be released. You are basically you are not removing them, you are releasing at different height, and they will transport, and they may cause some acid rain and secondary particulate formation and affecting on not at the local area, maybe it will cause a mostly regional air quality or continental air quality problems. You also notice something called a stack downwash. So basically you will notice when the plume is releasing, depending on the wind velocity, suppose if the wind velocity is very high, so what will happen, it will try to shear the plume which is releasing from the stack height. So in such cases what you will do is you have to adapt some correction factor for the plume height. So that will be estimated using a stack downwash equations. Sometime you notice that all the whole plume will come down. So this will definitely going to cause more emissions. The importance of the stack downwash, because since it is reduces its height, the concentrations will be much higher because you are correcting the effective stack height. Okay, you are making the corrections with the physical stack height by means of calculating the velocity of the emissions coming from the stack and ambient wind, and you try to estimate, make a corrections to the physical stack height of the industry. The next type of model you will come across is an area source model. Basically this is a very simple model, and if you want to quantify the emissions contributed by the various activities, quick you wanted to get some information on what is the concentration in a given urban area. So some of the assumptions made, they assume that the whole area is the mixing is a uniform mixing, it's a steady state concentration, no upwind background concentration, so there is no background concentration. So whatever the concentrations you are estimating is only happening because of the activities within this controlled environment. So here delta x is distance over which the emissions takes place, q is the emission area emission rate, and L is the mixing height, U is the mean wind speed through vertical extent. So the next type of model is a line source model. This is a very simple line source model where you will notice that Q is the emission source strength contributed by the tile pipe, then sigma z, and sigma z is the vertical dispersion coefficient. So I mentioned about horizontal dispersion coefficient, sigma z is the vertical dispersion coefficient, and h is the effective stack height, and sigma z is the again vertical dispersion coefficient. Here if you try to look at h is nothing but the release height. So for example, if the emissions contributed by a tailpipe, so you know the emissions are always move upwards. So this will be so these are some of the equations which you can use it for controlling the emissions contributed. So you have a sigma z is a vertical dispersion coefficient, and u is the wind speed. Okay, so you can find out what is the concentration. So I can, so you take a case, you assume there is a road and there are many vehicles moving. So you are interested to find out, like you have a bus stop here and wanted to quantify the concentrations if the wind is coming from here. So you can use the different number of vehicles, okay, then use their emission factor for each vehicle type, okay, then you know the number of vehicle, you know the ambient conditions, you can try to find out the dispersion coefficient sigma z corresponding to the ambient conditions, then quantify the concentrations. So you can able to estimate the concentrations using this simple equation. Okay, so then I'll try to introduce some aspects. Suppose if you you know there is a some engineering we discussed about the source control, some engineering design that can be adapted, mechanisms that can be adapted in removing the pollutants. So you can also remove pollutants with a green cover. So you can see that this is another way of reducing the emissions from the source. So I also mentioned about yesterday you can use mechanical sweepers for removing some of the dust which is deposited on the road. So you can this is one example for removing the dust from the paved roads. So the mining is another activity where you will notice that a lot of the emissions will be contributed here. The mining activity itself will contribute a significant amount of emissions. Then the movement of vehicles will contribute, and when they are storing some of the excavated material, that will also contribute some amount of emissions. So for example, in this case, if you try to look at it, because of the mining activity, the significant amount of emissions are contributed, and you would like to know up to what distance the concentrations will be spread here. So you can use either area source model, or you can set up your air mod and try to understand how the dispersion will going to happen in this particular area. So now the next approach available, see next this one is another example. If you try to look at now all the excavated material you have stored here, okay. So sometime because of the settlement, okay, all the large size particles will be settled first, and then the finer part material will be on the surface. So hence if there is a sometimes the wind blows, then all these finer particles will be get resuspended. Okay, so they will all again carry to the nearby area, they cause pollutions. Okay, so this is another activity, and movement of vehicles will also contribute significant amount of emissions. So sometimes you can also use a green cover in order to reduce the emissions contributed by the various sources. For example, if you on both the national highways, you can see that if you have a plantation on both the roadside, it can reduce emissions. It can contain emissions. So one way is you can also design some kind of an barrier on both the sides, so that all the emissions on the emitted from the road can also be contained within that area. So you can also adapt some sprinkling system. Again, this will also help you in reducing the emissions contributed because of the resuspension and other activities. Okay, so this again the more the green cover, so you will have there are two ways it will help you. So one is the green cover also, for example, this is an open area and this is a green cover. So obviously there will be some pressure difference you can expect here. So this will also enhance some local circulations. So because of the heating temperature variations between the surfaces, so this also can resulting into a small local circulations. In turn, that will also helpful in reducing the pollutants. Okay, the windscreen which I mentioned in the yesterday's, so you can have a mobile or a fixed windscreen. So depending on the wind directions, you can try to operate wind speed. You can control. So this will help you. Suppose if you notice that some activity is happening, and so if you want to control the emissions moving from that activity and impacting on the surrounding environment, so you can set up a windscreen on the upwind of the activity, so that all the emissions that are contributed by an activity will not carry forward. So the windscreen is another good example for reducing the emissions. Okay, so the next is cleaning of the tires. So sometimes, especially in the construction sites, you are noticing that a significant amount of the materials will be deposited or stick to this tires, okay, or the bodies of the vehicle which carrying the goods. Okay, so or if it is an excavated material has been transported by this vehicle, so the significant amount of the particles will be attached to the tire and also its body, vehicle body. Clean them before it go to from the side. So this is a manual cleaning, and other one is a mechanical cleaning. So where you know when the vehicle comes near to the platform, it automatically jet of water will be flashed on it, and both the vehicle body and the tires will be cleaned. Okay, so I think this is what a current scenario. For example, I just mentioned about the different types of sources here. Our Indian traffic, if you try to look at it, is more of an heterogeneous in nature. It means that different types of vehicles are moving in a same road. And so you may notice that the volume will be very high, but the emissions will be also much higher, because all these vehicles will be subjected to stop and go operations. Sometimes because of the congestions, there will be significant amount of emissions. Hence, you will have more air pollution problem associated with vehicles. So now, if this is the scenario, then how to bring it to a cleaner environment and reduce this traffic emissions. Now, if you reconnect all the whole discussions of the session 1 and session 2, in the session 1, we have indicated, so for example, if we want to reduce the emissions contributed by this kind of an heterogeneous traffic, I mentioned it to you. This heterogeneous traffic, if you try to quantify, at this case, and at least in this case, you will notice more autos and also significant number of two-wheelers and cars you will find out. Okay, so number of buses also very high. Now you will be able to, when you do an emission estimation, so definitely you will come across diesel vehicle emissions, and also maybe emissions contributed by autos will be significant when you try to measure the particulate or air pollutant concentrations here. Now, how to reduce this? So now you can have an emission inventory, then count these vehicles, identify the age, year of manufacture through your year of manufacture, then estimate their emission factor, diesel vehicle, petrol vehicle, try to find out how many kilometers drive, operation and maintenance. You just get all those information, then you will able to estimate how much emissions contributed by this number of vehicles. Now you use model. Now when you use this information by emission estimation, you notice that this will contribute by, say, about some X tons per day. Now because of this X tons per day, this particular area, maybe in this particular area where you measure the pollutant concentration, indicated that the concentrations are 200 microgram per meter cube. So if you recollect the particulates concentration as per the National Ambient Air Quality Standards, it is 100 microgram per meter cube. Now you want to reduce, okay, at this level by 100. So now how to control 100? So you need to understand what is the meteorological conditions that are dispersing in the emissions contributed by this. What is the worst case scenario? Whether you achieved 200 microgram per meter cube, is it corresponding to the worst case scenario, or is it on a normal day? So then your model will able to help you to quantify what is the highest concentration you can predict corresponding to this situation. Okay, now you have a measured concentration or you have a model concentration, you have a standard, you know how much percentage is reduced. Now assume that there is a 200 microgram per meter cube that is contributed by this vehicle under worst case scenario. Now the standard says 100 microgram per meter cube. Now immediate this thing is for you to reduce it to 100 microgram per meter cube, then you have to go for your tactical approach. Then you should say that RD1 policy or maybe increasing the emission norms, taxing here. Maybe if the vehicle uses, maybe it is a peak hour, then you can increase the charges, peak hour charges here, usage of this particular road, so that people will try to avoid or reduce the congestion in that particular place. That's one option. The second option, if you adapt that, whether the air quality will be improved, you can check it. The other option is based on your model, you can also identify which source you can reduce it, because your emission inventory will help you to quantify which are the different sources that contribute. For example, here in this case, if you try to look at, there are 4 or 5 buses that are contributing. Okay, these buses are more. So then if you convert all these buses to a CNG or all these buses to electric vehicles, then that much amount of emissions will be reduced. So now you see that whether if you adapt that policy, then whether the emission concentrations will be, the ambient pollutant concentrations will be reduced. So your model will help you in reducing the emissions. Now I wanted to summarize my whole discussions with from the yesterday's point and from yesterday's session and today's session. So you can use from the emissions control at the source itself. Maybe you can use some catalytic converter. For example, you can think of engine modification is one such thing. Now there are better efficient engines are coming up, and hence the emissions are also reducing. So that's why your Euro norms or Bharat stage norms basically looks that kind of technology that is available. That is why it is a long-term strategy. So whereas in the short term, so in also you can also look for example, you have old vehicles vehicles of more than 10 years of age, and still you would like to reduce the emissions contributed by this 10-year old vehicle, then you should look for some kind of an arrangement to control the emissions at the tile pipe itself. For example, fitting one catalytic converter or a filter, so that can also reduces the emissions from these sources. From the out of box solution, so for example, all of us know that in an urban area, storm drainages have been designed to remove water flow, to carry water during excess rains. So then you can use that. Now if you know the number of rainy days in a particular area, so then the usage will be limited to few days in a whole year. So for example, you can use this as storm drains or the pipe structures to pump this polluted air. For example, in this particular area it is highly polluted. Now if there is a storm drainage is available, then you can pump the air from this to outside. Then there is a possibility of recirculation. So these are all some of the solutions that can be looked in order to reduce the emissions contributed by the various sources, so that you can bring the highly polluted environment to a cleaner environment. So in a nutshell, I would like to summarize. So you need to characterize the emissions contributed by different sources. You need to identify which are the key pollutants that are contributing emissions. Then you need to look for what are the control technology that is available in order to reduce these emissions at source. Then you look for how to use model in order to design some of the policies in controlling the emissions. I think I would like to suggest you to go for some of these books chapters that are very useful for you to preparing. I've used some of these chapters. Now the floor is open for questions. Okay, the first question is what are the velocity profile of inflow gas in settling chamber and how it is related to the length of the settling chamber. So as you know that settling chamber is basically the particle size determines, okay, depending on the particle size you can decide the dimensions of the settling chamber. So your length and height will determine by the size of the particle. So again you can decide the cut size that you need to be removed from the settling chamber. So you can have a different velocity profiles using the Stokes equation. You can find out at what gradient the particles will be removed. So the next question, why mixing height is less in winter as compared to summer. So as you all know that the mixing height is determined by heating effect. Okay, so in the summer, the incoming solar radiation will have a more warmer it will heat the surface. Okay, so hence the air will be much warmer. So hence you will going to get more turbulence, more flow of air molecules. So hence the mixing height will be generally very high during the summer when compared to winter. So winter you will have because of the temperature inversion. So you know that so the dry air parcel, because if you release an air parcel of temperature, it loses to the surrounding environment by adiabatic means. So in the temperature difference in the summer will be much higher. So for example, outdoor temperature will be about 40 degrees. So you will have a more volume of air that you can be available for the air mass to move in a upward direction. Whereas in the winter, the temperature difference, okay, will be very less. Basically, winter will be having the difference between the air emissions and the surrounding temperature will be much less. Hence, the mixing height will be very less. What type of particle cause interferences in ESP? Okay, so what type of particles causes ESPs? Sometimes the particles of sticky in nature, so they will be a major problem in ESP. And also sometimes if the particles of not carrying any charges, then those particles also problematic. Okay, why plume is not directly move upward in case of looping? So basically, it's because of the highly turbulent conditions in the ambient environment. Hence, the plume will spread. It's because it's highly unstable. So because of the wind velocity and the turbulence nature, so the plume shape will be looping in highly unstable conditions. Okay, what are the various mitigation strategies for controlling urban heat island? So urban heat island is, I think I will discuss a little more on tomorrow, because one of the case study which I mentioned is also have some information on urban heat island. Okay, so regarding the mitigation measures, obviously we should increase more green cover in order to reduce the urban heat island effect. And of course, we need to reduce the emissions that are contributing, because basically the urban heat island effect is happening because of more CO2 emissions releasing in that particular area. So we need to address reducing the emissions in that particular area. Okay, which mode of transport we should adapt which can cause reduced air pollution? So all vehicles, if you use any fuel, will cause pollution. So I think bicycling will be better, or by walk you can reduce air emissions. Of course, you can, if you are essential to, modes of transport again depends. My traffic engineering colleagues can explain this better. If you are a shorter transport requirement, for example, if it is less than 0.5 kilometer to 1 kilometer, it is better you go by walk. If it is between 2 to 3 kilometers, you will go by bicycle. Then more than 5 kilometers to 10, so you can go by bus, car, something like that. So the distance determines you which mode of transport you need to adapt. I think in the incineration, after passing the pollutants through a flame, will the catalytic bed be able to absorb effectively the pollutants? So incineration is basically you are trying to eliminate all the unburnt hydrocarbons or any other waste materials that are existing. So I think you can. I'm not sure about how you can integrate that catalyst bed. If your catalyst bed is meant for increasing the temperature. Basically, if you, in the incineration, the catalyst will be used to maintain the temperature. So hence, their role is to make better combustion. So maybe after your incineration chamber, you would like to still would like to capture some more, because incineration itself will try to eliminate all the pollutants that are uh, 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 existing. So I think the absorption is not required. Okay, how would we classify different pollutants in air which contribute maximum air pollution? Okay, so the question may be, so as you know that, for example, if you try to take many of our Indian cities, the air pollutants, we declare many urban areas are non-attainment areas based on the monitoring of monitoring of air pollutants by Central Pollution Control Board under National Ambient Air Quality Monitoring Program. So in most of the cities, we notice that the pollutants like particulate matter is very high. So now, which contributes particulates matter? If you try to look at some amount of, if you look at the source apportionment study of the 7 cities, they indicated. So different proportionate of particulate proportionate being contributed by vehicles. For example, some areas the contribution from vehicles is around 20%, in some areas it is 30%. So apart from that, resuspension is also contributed significantly. So generated particulates generated by generator sets. So there are different sources. So among them, if you try to look at some places, if you are measuring at a traffic site, obviously vehicles contribute significant, including resuspended emissions. Is the indoor air pollution worse than outdoor air pollution? So a very interesting question. So one of our earlier research, we try to understand, either because of the schools are located, the adjacent road became heavily trafficked, or because of the better connectivity, schools are located very close to the urban roads, roads having heavy traffic. So now, sometimes what happens, schools will have a ventilation. So all these pollutants released from movement of vehicles or industries. Okay, so these pollutants will be get trapped in the indoor environment, and sometime you notice that indoor pollution will be much more higher than outdoor pollution. In addition, indoor pollution, sometime in the classrooms, you will also notice student activities, like when the teacher is not there, then the movement of the students can also contribute a significant number of resuspension. So hence the concentrations will be in the indoor environment will be much higher when compared to outdoor environment. So what process modification at the source reduces the emissions? So process modifications here I mentioned about, there are different types of engine modifications. For example, if you want to adapt the Euro 6 emission norms or Bharat 5 emission norms, then correspondingly engine modification is required, fuel modification is required, that can reduce significant amount of emissions. I already mentioned about converting 2-stroke engine to 4-stroke engine itself has reduced significant amount of emissions. Okay, so see, line source emissions is, as I told you, there are different types of models. The models have been specifically addressed a particular type. For example, for point source, Gaussian plume model will be useful. For line source model, which I mentioned, you can use a simple line source model. Suppose if you want to use both, okay, I told you the air mode is a commercial software that involves area source, line source, and point source. But if you want to do it as an exercise, you can club point source, quantify the emissions. use the line source, quantify the emissions. Basically, concentrations at the receptor is a superimposition of the emissions you are estimated, or the concentrations you are predicted by line source and point source. The use of Pascal Gifford stability curve to estimate the model parameter, that is sigma y, sigma z dispersion coefficient. Okay, super adiabatic flume is nothing but your dispersion condition is highly unstable. It means that plume shape will be looping. How to treat air fumes coming from geothermal plants? So if it is coming from a fixed location, you can treat them. You can treat them as a ground level source. Maybe if it is an area is large, then you can consider them as an area source. Okay, what is an air quality index? So air quality index is a summarizing the pollutant concentration, an index. Basically is a segregating the various pollutant concentrations into an useful numerical value which indicates that quality of air. So for example, the air quality, if you are saying that 100 microgram per meter cube and standard is 100 microgram per meter cube. Now if you say air quality index is 100, it means that you are violating the standard. So 100 microgram meter cube can be converted into some number, numerical value. So that indicates air quality index. Okay, so a very good question. Can there be a conceptual community mechanical air purifier for residential area near residential area or industrial area? Okay, so I think they already started making a kind of bus shelters adapted with industry air purification system. For example, cyclone separator with electrostatic precipitator, they are adapting it. And we are also now working on in these directions, try to design some air purification system for community air quality management. Indian models, what you are have the equations which I showed, you need not to pay for them. So what you need, the thing you need to do is you have to code them in MATLAB or some C programming languages. So you can use those equations, create your own database and use them freely. You can also use these models on an Excel spreadsheet, and still you can estimate concentration variations. On what factor dispersion of pollutant depends? So there are two major factors that influence the pollutant dispersion in an ambient environment. One is stability of the atmosphere and the wind speed. Features of the baghouse. Again, baghouse you can say you can have different fabric materials, understand the requirement for controlling the different sizes of particles. Okay, so you can go through that some of the points which I mentioned there. So as I told you, it only indicates, for example, if the plume is coming, okay, how it is horizontally spreading and vertically spreading. So that will be explained by the deviation, that the deviations from the mean. Okay, so that will be explained by your horizontal and vertical dispersion coefficient. So that we call it as a model parameter. Just to give an idea to you, for example, if you lighten an agarbatti, and agarbatti, if you just notice how the agarbatti smoke will spreads, so it will go vertically. So it will also spreads horizontally depending on the concentration gradient. So the diffusion, the molecular diffusion happening because of the concentration gradient is captured by your dispersion coefficient. Now, if you put a fan, so the spread will become much more stronger. So that component will be used in explaining how the dispersion coefficient dispersion is happening under various conditions, okay, using some field experiments. So those charts have been developed. So you are using those two coefficient to understand how the vertical and horizontal dispersion happening on a given environmental conditions for a particular source of emissions. What is baghouse? What is the advantages? So baghouse is nothing but one type of control equipment basically used for removing the pollutants from the source. Okay, so as I told you, when you don't have an informations on size details, so you can use baghouse for removing the pollutants, and if you wanted to reuse the collected materials, still you can use baghouse. So what would be done to the wet scrubber disposal? So I think it again depends on what kind of waste material that is being generated in the scrubbing activity. For example, if it is a very toxic in nature, then it need to be disposed of to send it to hazardous landfill sites. Or if it is reusable, then you can alternately you can think of reusing for other purpose. So EIA is important for air pollution control. So basically, EIA, environmental impact assessment, will indicate. So for example, any industrial activity that need to be identified whether the particular activity will going to contribute some significant impact on the surrounding environment. So EIA studies are being carried out. So that will indicate that whether air pollution impact is significant. Then you will develop some remedial measures. For example, adapting some control air pollution control. Just take some proponent is proposing for a thermal power plant. So a 500 megawatt thermal power plant. So then if we notice that he is setting up at an industrial area, and at that industrial area already the concentrations are near to the specified standards. So then if you allow you to set up there, the concentration in the industrial area will be exceeding. So what they will do is then they will try to adapt the EIA methodology, EIA, to understand how much the contributions from the proposed industry. Then if it is going to cause a significant impact, then they will suggest, okay, how much emission reduction has to be carried out. For example, it has to be reduced 50%. Then for 50% reduction, and depending on the kind of fuel combustion you are using, you are able to design, okay, what kind of control equipment will able to help you in achieving the 50% reductions. So that is what your EIA studies will going to help you. Okay, that's all now. Thank you very much. If you know more questions, still I am open for discussion. You can write an email to me, and we're happy to answer any of the questions which I missed to touch upon during these discussions. Thank you very much for your patience listening to these discussions. Thank you very much.